this number right here, 0.000210. Oh, I like this one.
It's 2.
How do you turn this into scientific notation?
2.1. Or say it.
The first thing you should look at is the first non-zero number. I'm just going to walk you through it right now. I'm glad that I just asked the question, but I'm going to walk through it. You go to the first non-zero number. Is this all getting recorded?
Yeah.
I'm going pretty high up and down.
Here, I'll
no, it's fine.
I'll hold it down.
Okay?
What is this for?
Scientific notation. So this is going to be 2.10. Alright?
Times negative.
Now it's going to be times what?
Negative 4.
Times 10 is something. We don't know what that something is yet. Oh my gosh, I'm just going to put a blank there. Just something there. Because it always goes into this kind of form. It always goes into this kind of form right here. Alright? So you want to see how you can change this number, exactly what Alexa was talking about, how you can change this number back into this one.
Negative 5.
So what you do is you take this decimal. Where are you going to move it? You're going to move it this way or you're going to move it that way? Right or left?
Left.
Left. So since you move it left, you know it's got to be negative. So let's do it. We're going to move this how many times to the left? We're going to move it 1, 2, 3, 4. So it's going to be the negative 4. That's it. Question?
So left is negative, right is positive.
That's
Gotcha.
Got it.
fuck. Mark, guess what? You can leave. Really? Yeah. You actually got kicked out of the review session. You don't need to be here. You're just causing trouble.
Mark.
What is on my floor?
So, any other questions?
So basically, it's just the amount of zeros after the decimal point plus 1.
Yes.
Is a negative.
Yeah. You can put it that way. Yeah. Okay? Go, Gene.
What type of questions are you going to ask us based on mixtures of substances?
Mixtures and substances, similar to like fill in the blanks, conceptual questions.
Will you give us like the diagrams to fill in the blanks?
No, I won't give you the diagram. You can write the diagram down if you like. That helps you. It's really a small flow chart.
Yeah. And is there a lot on it?
Is there a lot on the test?
On the mixtures and substances?
No. We've only covered it for the last week. So
Yeah.
we've got a longer time in school. Yeah.
Could you ask us about accuracy and precision? Like, are you going to ask in a section, or are you going to ask about, like,
Ooh,
maybe a big cell?
like a problem about reporting your measurement of precision or reporting the percent error. I definitely will ask you about that. And it's going to be, I just was whipping up a really tricky one just now.
Oh God.
It's
Can you
going to
go
be fun.
right?
Oh yeah. Love these problems. Yeah, use calculators. Honors, don't forget sig figs. Always sig figs. Report sig figs all the time. Okay. And keep your units. That's for everybody. Keep your units. Don't forget writing down the units. Use a calculator. You'll get a, tomorrow I'll give you the formula sheet, all the things that you're going to get for the test. I'll give that to you. Yeah, I'll give that to you tomorrow.
Question. Conversion going to be in the test?
Conversions. Yeah, definitely.
You go over that.
Sure. You guys have your packets, right? So convert, I'll do an easy one. Convert 5.692 times 10 to the 5th miles into kilometers. Do that. That's what we gotta do. So how do we start setting this sucker up?
Well, first you gotta convert it.
Standard notation.
You don't have to, but you can. Sure. So let's do it. So it's going to be 5, 6, 9, 2.
6.75 miles in.
Yeah. And then do the King Henry.
We don't actually need to do that. There's an English to metric conversion table.
Then you multiply it by 1.6.
Are we gonna have that on the test?
Yes.
Oh,
He
yeah.
asked that. He answered that. So for every single mile,
There's 1.6 kilometers.
there's 1.609 kilometers.
Well, we have to memorize that.
Nope.
We
That's
get
gonna be on.
the table.
Yes, just instead twice. Miles. Cross off. All this is now is a multiplication problem. Now, what if we wanted to do the exact same thing, except instead of, okay, we can actually, you guys want to find the answer to this? I'm getting ahead of myself. Let's find the answer to this. This is 569,200 times 1.609. So the answer is 2.8. Now, for general, that'd be fine to report it like that. But for honors, of course, you need to report it to the correct number of sig figs, which would be 1, 2, 3, 4. So you would have to route it right after the 8. 1, 2, 3, 4, right there. So your final answer for honors would be, it'd have to be this. It'd have to be this. 915,800. And then, of course, kilometers. You could also put that in scientific notation if you want to, but
So just
That's
to
what we're
clarify,
excuse me?
or just to clarify, you really can't leave a decimal when you round, because then that would mean there's 6.
Yeah, you really, well, you mean right here?
Like when you round it, you
Yeah.
can't have a decimal.
Yes, don't put the decimal there. But what, let's see, what would happen then if, instead of miles, I was going from kilometers to miles.
Isn't it, oh yeah. Alright, never mind.
Kilometers to miles. This would be different, right? How would this be different?
You put,
Yeah?
well, you have to divide.
Yeah. Instead of this, it'd be kilometers. Oh my gosh. So now this would all flip around.
Oh.
Oh,
Now it would be
1.609
1 mile for every 1.609 kilometers.
That's why I don't know.
Oh man! So we just flipped it around. Now we've got a completely different answer.
sweet.
Whoa! What do we do now? It's not multiplying this, it's taking this number and dividing it by that number.
Oh,
That's the same.
Yeah.
So, how would you know that by looking at the table? Like,
You know that by looking at the table because
The
all the
opposite one?
English units are 1, and all the other numbers are the metric units. Okay, so for every mile there is that many kilometers.
Yeah,
For
but-
every acre there is that many meters
you
cubed.
switched it up, so it's like km here
Yeah?
and this miles there. So how do you know like when to divide this?
You just know that for every single mile there is that many of those metric units. Okay? Think of those as belonging to the metric units. Those multiplication factors. I wish there would be an easier way to do this, but for for all those units, they're attached to that. For those units, they're attached to that. That one's attached to that. That one's attached. These are all just 1. Okay. All right. So for this one, you take that big long number, the 569,200, and divide that by 1.609, and you get for an answer. Get something funny? You get something like this. 0094. But for general, where would you round that to?
2 significant.
To general. I'm saying that one more time. To general, you'd round it to the 1, 2, 3. You'd round it to 3 decimal places, right? Always 3 decimal places.
Oh, okay.
But for honors, where are you going to round that to?
Sig fig.
Yeah. So how many sig figs? 4. 1, 2, 3, 4. 1, 2, 3, 4.
He said the people that's in general don't listen.
That's it, right there. Ta-da! Funny, isn't it?
Wait, so you round to 3.
What do you have yours?
Did I do something wrong?
When we were doing miles to kilometers, you said like rounded to 5 sig figs. Wait, no, wait, you said 4. Never mind.
Okay. Any other questions? That's conversions. Yeah.
So when we're adding with 6 figs, then
Yeah, which rarely happens. You
Right.
maybe get
But
one.
that's-
Divide.
you add the term to the uncertainty, place, or is that
So
physics?
you multiply these.
Right.
When you add, you have to, you keep it, you round up to the least certain place.
Yeah, you could say that. That's another way of saying the decimal places.
Yeah, that's.
Yeah, right, exactly. Good. Other questions? You're pretty good, Alex. You look confident. Like it. Anything else?
I'm trying to.
I'll give you guys a couple of minutes just to look through stuff right now, just so you can look through your workbook, see if there's anything you got some worries about.
You go by accuracy and precision again.
Accuracy and precision. Yeah, let's do it. Accuracy and precision.
Wait, what?
For those of you who want to leave, you can leave if you want. You don't have to stay. Just be quiet when you do leave. So here we go. Accuracy and precision. Accuracy, you measure it through what? Percent error. That's right. Percent error is the, what is it? Actual
Value.
minus the measured all over the actual.
Wait, you put
Times
does that mean it's absolute
100.
value?
Yes, absolute value. Okay? That's percent error. Alright? That is percent error. So this whole thing equals percent error. So what I could do in a problem would be to give you the percent error and maybe the actual value and say, what's the measured value? And you should be able to figure that out backwards.
By dividing.
There was one problem, I think it was an in-class or an in-class problem that we did that was kind of hard. That was just like that. But most of the time I'll give you the actual, I'll give you the measured, and I'll say what's a percent error. Now, for measurement of precision, it's a little bit different. Precision, remember this? Precision is the average value plus or minus the range over 2. Okay? So if I give you a set of values like 1, 3, 4, 5, okay, you find the average of all those. Let's do 2, oh, that would be 7. So you find the average of all those, you add them all up, divide by 5. What would you get? You could get 4. You get 4. So that's the average value. And then the range is going to be the highest minus the lowest. So in this case, the range is going to be 7 minus 1.
Divided by 2.
Divided by 2. So it's going to be 6 divided by 2. So the final answer here, it looks just like this, is going to be 4 plus or minus 6 over 2, which would be 3. That's it. And if you have units, let's say that these had units of centimeters. These are all centimeters, and this would be centimeters right back there. Okay? And that's how you report precision.
What about the darts?
What about them? Oh, you remember these darts?
Yeah.
Dartboard right here.
Did you say what accuracy?
Yeah, accuracy. Accuracy is hitting this bullseye. Boom. That is accurate. Accurate right there. What if you hit the outer ring? Is this accurate?
That's precision, not
No,
accurate.
but it's very precise because all of these little darts are hitting very close to each other. So you can say maybe precision is closeness to other measurements, closeness to other values. Well, accuracy is closeness to the actual value or intended target. Okay? And then you have like a whole bunch of these darts that are all over the place. There's no accuracy, there's no precision. Yeah, I think we're about done. Any other questions?
What if like the dots are scattered, but then one of them was like
Oh,
in the middle?
yeah.
Is that like accurate?
Yeah, there's, I like to hear people argue one way or the other for that. So when people argue, then they